Thank you once again. Thanks for joining. So every week we'd like to call out a few people those we think have put in a lot of work into their project. So I think shout out this week goes to Fumi. Yeah, I know it's not easy, but I really appreciate the fact that you are really putting a lot of shift into it. So well done. Obviously, working from Nigeria is not even the easiest thing. So, but despite the odds and the difficulties, you're really, doing a good job keeping up with the class and doing the project. So well done. And then keep the fire burning, please, because it won't get any easier from here. That's the honest truth. And so well done. Well done. I'm not even sure she's on here. That would be a shame, but at least it's being recorded. So. I think she's here. Cool. Someone raising their hand. Yep, go for it. Anyone ask any question?
Yes, that's me. Good evening, sir. Um,
Hey,
Hello, can
Wale,
you
what's
hear
up?
me?
Yeah, I can hear you. Yeah.
Yes, I'm okay. First I want to apologize for my late submission this week. I was a little bit held up this week, so that's why. But my submission is still coming through tonight. Um, I'm going to drag us back a little bit with my question. I'm very sorry.
No worries.
So, it has to do with my Terraform code.
Mhm.
So I just want to ask, is there a way that I can specify directly from my Terraform the ports where I want my node to operate
Yeah,
instead
we
of
will get there.
doing it
Yes,
manually?
yes, yes,
Okay, okay.
yes. We will
Because
get there.
I'm like, because I'm present, like I said, I'm presently doing it and it's going to come through tonight, the submission. So I'm
Hmm.
like, how can, I was not, I was, I'm now thinking about how I can, play around it and just include
Hmm.
the port straight from the Terraform instead
Of
of going back
course,
to the console
of
to now
course.
change the, okay.
Yeah. So what I
All
what
right.
I try to do is I don't try to front load us too much with too much information. So the approach I normally take with teaching this stuff is to go easy. And then when we establish some confidence, then we can go really hard. So of course, Terraform allows you to do that and more. And we're going to be exploring that. So it's going to be like an onion. We're going to be peeling it layer by layer. And our last step would be give us the support that we need to get to the next steps. And we're going to kind of go in one step after the other. So you're in safe hands. You're going to be able to do a lot of wonders. Just a bit of patience. I haven't seen your work though, so I'm hoping send it.
Yeah, it's
Cool.
coming through tonight after the class. Like I said,
Fantastic.
I'm still working on it. I am supposed to submit earlier in the
That's
week,
all right.
but
That's all
because of
right.
different engagements, so
Oh
that's
yeah,
why
of
it
course.
was a little
Of course.
bit
It's
held
not
up this week.
easy. We know
I'm so
that.
sorry. I'm so
Oh no,
sorry.
no, no, no.
So
Please don't
after
apologize.
class tonight, it's going to come through.
Yeah, don't apologize. Sorry, who is WAB? Is
Thank
that
you, sir.
Wasiu? Don't worry, well. Who is WAB? Is that Wasiu? I don't know who WAB is. Hmm. A lot of names here. I know Ajana now. That's for me, I suspect. I don't know who WAB is. Okay, I have my good ladies here, Cynthia and Mommy. Welcome. Okay, guys, so just a few info here. So I want us to kind of wrap up for the year, week on ending on the 14th of December. So we have, let me get the calendar out. Bear with me, please. Okay. Are you able to see my screen? Can you see the calendar? Guys,
Yes, we
can you see my
can.
screen? Okay,
Yeah.
cool. Fantastic. So this is where we are, the 22nd. So we're gonna have a class today, tomorrow, and then the 29th, 30th. And then we do 6th, 7th, 13th, 14th. So this is where we stop for the year. So we will take the week ending on the 20th off and the week ending on the 27th off. So we meet again in the new year on the 3rd. Potentially we might extend it to the 10th, but I'm looking at the 3rd. Um, so this week we're gonna be off the 15th all the way to 21st and the 22nd to 28th. So basically when we go, when we the break starts on the 14th, so we won't meet again until the new year, potentially on the 3rd, but it might be the 10th. So what we do this period is you would have a start. So we still have about 4 weekends, 3 weekends to kind of, where we meet. Essentially, we're going to have a project. So it's going to be our first major project that will come out on the 15, 16. So we can play with, we're going to be able to play with that for about 2, 3 weeks period. So it will be a sort of like a combination of all the things we've learned so far. We're going to be putting that into work to go over the project. It won't be the easiest project. Yeah. So Cynthia, yes, go for it.
No,
Yeah, can you hear you?
sorry. So it's just a request.
Yes.
I'm just requesting if we can resume on the 10th, as we know that the new year there are so many programs going up and down, like it's festive.
Yeah,
Well,
yeah.
please, that would be really nice if we can start.
Yeah. So if you guys want us to kind of, I'm thinking third, but if you guys want us to do 10th, honestly, it's not a bridge I'm prepared to die. I'm more than happy to extend it to the 10th. So let me know, guys. You can just drop a comment on the here, not on the Slack. Just drop it here. So it should be an opportunity for people in class to decide the fate of everyone. So so if you want the 10th or this on the 3rd, so you can so we're gonna let the consensus have the day. Yeah. And then if you like Cynthia, you do the 10th. If you don't like her, say the 3rd. Okay. Thank you very thank you very much. Alrighty. So we before we
Last,
kind of yes, go
last,
on. Go on.
please, can we do Azure a little bit? I know I'm just making a request, but yeah.
We won't do Azure. We're gonna touch it here and there because it's gonna confuse the class.
Oh,
But
okay, I
I'm
see.
more than happy to, help you touch things here and there.
Okay,
If
then that
you,
means
yeah, yeah.
because I'm using a different thing entirely. I'm
I
trying to,
know, I
yeah.
know.
All
But
right.
you're a seasoned Azure person, so you should be able to figure a way. But we're here to help you. That's why you paid a lot of money for it. So if you need support,
Okay.
definitely reach out.
All
Definitely.
right. Yeah, thank
Yeah,
you.
yeah.
Sorry, some of us wants to learn, we want to learn Azure as
No,
well.
no, no, no.
When
So
Cynthia,
this is
no,
this
no, no.
is this
When
is not
Cynthia, when
this
you're
is
touching base with Cynthia, if some of us can tag along,
absolutely, absolutely. But it has to be targeted. So if there's something you want to know specifically, we have a session
we'll
on it.
run by
So
Cynthia. Cynthia will be our champion.
okay, all right, cool. So obviously the my main objective is to protect the class so we don't kind of, drift and people get confused. Yes, Cynthia, by all means. And anyone that needs help, whatever it is, Google Cloud, Oracle, whatever, just reach out to me. I'll make it happen. Thank you. So, guys, before we wrap up for the year, we will cover a key few things. We are going to today we are doing something interesting, CICD. I'm going to shed some light on that in a bit. Also, we're going to cover introduction to configuration management using Ansible. So those are the big few things we're going to cover. And also we're going to extend our knowledge of Terraform. So it's going to be a lot of Terraform, a lot of CI/CD, and a lot of Ansible. And then we're going to see what role each of these plays. I think we kind of have an idea of what Terraform does, so, but we are going to dig a little bit deeper and kind of go to the deep end, especially that will be useful for people that are preparing for their exams. I've only seen two names, by the way. I've seen Wiley and, and Ahmed. I need more names of people, putting their exam prep and booking their exams because the exams will change in the new year. I think we already established that in the exam column. Please, guys, the only way to do well in this field, you can ask Cynthia, people that are using DevOps, you need a lot of exams. You need to write. If you don't have exam, they won't even pick up it. They will not even touch a CV with a stick. They won't let them know picking it up. They will not touch it with a stick. So you've got to write exams, and if you want to like play within the time frame you're looking for you to secure a job, you got to do exam and gotta just front load them as much as possible. Also, the market is not getting any easier, so it's the survival of the fittest. Even with exam, even with certification, there's no guarantees. from the next year, I'm going to be working with a few who have paid for the service to help them rejig their CVs. And what we're going to do is we're not cheating, but we're going to go with faith. And we will front load your CV with those certifications, even if you have not secured them. So we're going to say, okay, you need this the certification, you need that, you need that. We're going to front load it on your CV. That will obviously put you under pressure to go and write those certification, but we'll put them on your CV because it is not when you get the certification. There's no guarantee that you get the certification today, you get a job tomorrow. So we'll front load it, and then we ahead of time we'll be searching for those roles. And then hopefully as you're searching, you are preparing. So that you don't write the exam and then you wait for months. So you front load it, put it in the market, and then we go from there. So it's going to be cutthroat. It's going to be push for people that are really, really looking for to get in a job. For people that are comfortable, Bob is already your uncle, so you don't have to worry too much. For people that are really desperate to cut in the market, it's gonna be blood and sweat. I'm sorry. So, but I'm here to kind of guide you and suggest the best way possible to break into the market. Thank you. So Ansible, a lot of Terraform and a lot of CICD. Okay, back to today's class. So I think the journey so far has been, by the way, this is going to be class 11, Introduction to Continuous Creation and Continuous Delivery, CICD. Some call it continuous deployment, some call it continuous delivery. The lines to be blurred and answer what I mean. Technically, they mean two different things, but I don't want to go into that too much for now. But essentially, this is what we're going to be looking at today. Let me see, let's prepare my course. Yes. Okay, so the continuous integration side of things is basically how you will automatically run your code, which you call that the build and the testing of your code. If you recall, let me just take us back a little bit. GitHub. I wanted to mess up a little bit. Okay, all right. Okay, if you recall, we've been playing with this repo for now. This is going to be the main repo we'll be using for this program. And if you recall, in this repo, we looked at the front end, which is this sort of the HTML, CSS artifact, which we have used to generate the front end. And we said the front end is powered by the back end, which is in this case Python and Java. And Java here. And it's using Java as an example. We don't have a readme file. Okay, using Java as an example, we said for the Java bit, we needed to kind of let's go back here for the Java execution. We needed to obviously install Java, and then after Java installation, we then try to run the code. But what we've been doing up until now is we've been basically been busy by setting up infrastructure and then laying of the binaries we need, which are the packages we need, installing them, and even going as far as downloading the code that we need to run on a machine, and then firing up whatever command that executes that. Okay. In a real life scenario, people don't really do this. I'm going to show us how we currently work and how things probably should work in a real life situation. So let's load this up and then let's do some chat. Okay, and then let's do this. Let me save this. Let's call it class 10 2025. Just bear with me. Let me save it on my disk. Voila. Cool. All right. So let's take all these out. Okay, so what we have now is we've got two streams. Okay, we got stream one, stream one. We're gonna make it, we're gonna do that all green, and we're gonna do stream two, maybe all blue. So stream one and stream two. So, so stream one, that basically allows us to manage infra. And then I'm gonna explain this a little bit so that we understand it. And we're gonna have stream two, which is up, up. And then this is infra. Okay, so let's label this green, let's paint this blue. Okay. The point I'm trying to make here is we've been working on two fronts. One front has been managing the infrastructure that we need. So if we go to this diagram, these are for this application to work, we would need an Apache web server. We would need Apache web server. We would need Python. We would need a node for Apache web server. We probably would need a node for Python and for Java. Okay. Our job is a little bit complicated because we are going the infrastructure as a service route, which means that we will have to manage our infrastructures ourselves. So the provisioning of the VM, the virtual machines that we need, we are having to manage that by ourselves. I always try to reiterate it that this is not how it always work. It always work in an enterprise system. Sometimes they don't deal with VM at all. They just go for the PaaS option, where they will have an existing platform that runs some sort of web server, so they won't have to be dealing with, VM installation, etc. Same goes for Python and for Java. So sometimes they don't go for infrastructure as a service model, they go for PaaS model, where you just basically deploy your application without needing a VM. You just deploy it on a system and on a platform, and then that basically spin up a system for you behind the scenes. I'm going to quickly show us that. I'm not going to get it to the finish line, but just to show you that VM is not always the option. But the VM, obviously, you have more control than using a PaaS option. For example, if you're on the AWS platform, there's something called, I think, Lightsail. Yeah, Lightsail. So this allows you to basically do PaaS option. And then there's something called Elastic Beanstalk. The Elastic Beanstalk is the way you will manage Python application, Java application if you don't want to do a VM. So you just create an application, you give it a name, you set your environment variables, you upload your code, you can specify where the code is, you can say it's a local machine. So the point here is you won't have to do any VM. You just put your code, for example, in this case, we're going to explore this at some point. And example, in this case, you're going to say, okay, this is my code, is Java, and you're going to specify the kind of code that you need to run. Is it Java? Is it Python? You're going to specify it. So this is a web server, for example, if you want to do HTTP. So this will be the web front here. This is active. If you want to set up a web server without having to do a VM, you just say you want to set up a web server, and then you give it a name. If it's not a web server, it's just a worker node. Then you're gonna have to provide the kind of application it is. So yeah, this is what exploring. At some point, we're gonna explore it. Some people go this route and then they don't do VM. So you go to their VM, there's no VM setup. Everything is just pass instead of infrastructure as code. And then a lot of pass options. So this is not just Elastic Beanstalk. So there are a lot of pass options, but it's just to tell you that that's one way. And we're going to look at that at some point. But what we've been using is the infrastructure as code route. It enables us to understand the basics of everything and also an opportunity to learn a bit of Linux and virtual machines. So we are getting a lot of advantages from that, but it doesn't necessarily mean that that is the only way to deploy applications. And the reason why that is of importance is if you're going the pass route, you might not be doing anything at infra level. Because, for example, at infra level currently now, we will have to set up we'll have to set up VM. So this is where we set up the VM. So a small VM there. Bear with me, please. Let's see. The VM here. Okay. So for example, we might have a VM for the Python code for web, VM for Java, maybe Python, whatever. So this is the infra route, okay? Infra route infrastructure that your code needs to run has to be set up. So you're gonna have to do this, obviously, maybe the manual way or using Terraform. So now we've moved to using code to building it. So we can say Terraform code, maybe in GitHub can basically help us set up our infra, yeah? So there's the infra task using Terraform now, and there's the application stream as well. So this is after the infrastructure has been built, we then need to deploy our applications on them. Okay, deploying application on them means that, okay, for example, this one, we're gonna have to deploy the web side of things, the Python side of things, and the Java side of things. Obviously, this you would have done in your last project. So it would mean that the Java code goes on it, on the infrastructure, your Python code goes on it, and your web code goes on it, and they'll be on different machines. The way this will typically work, the way we have been doing this is obviously we have the, let's call the app code in repo, and then basically, and that gets deployed on here and maybe here as well. So we've been targeting and doing the app deployment on these two machines. So, but we always have two tasks to do. We have the Terraform code, which we use to instantiate our infrastructure, and then we basically have sort of like a manual way where we do git clone, and then we just execute those applications on the VM. So we'll connect to the web, and we're gonna run like git clone, and then we'll copy some file somewhere, blah blah blah, and then we have our web server running. Okay, same way here, we would connect to the Java code and Java VM and the Python VM, and then we'll execute some. We would download the repo on the machines, and then we will then execute whatever command that gets our Python application working or Java application. For example, in the Python case, we will run this pip blah blah blah, and then for the Java in the Java situation, we'll run this and so forth. In reality, people don't log on machines to run code. So what they do is they will use an engine. So let's say we are still using the VM, we are still going the infrastructure as a service route. But instead of actually, because let's say infrastructure is set up using Terraform, maybe from the tool server, you set up your infrastructure. And then you now have the infrastructure, you now then logging into each of the machines and doing all the necessary work. You could potentially use automation to do all your Java code execution, web code execution, and what have you. So instead of you having to manually log onto those machines to top them up and run whatever you need, you can literally use automation to do that. And the way things actually work in real life is you remember that this code is not your code. So the Python and the Java code and the web code would have been written by a developer. So what typically happens is the developer will want to test the code anyway on a platform. So they probably will test it on their laptop. But at some point, they will want to deploy the code to a what they call a dev environment. So a dev environment is an environment that is not their laptop, but somewhere in the cloud where they can test the code outside of their laptop. If they are testing the code on the dev environment, so the way it typically will work is this. So you've got a developer. So it's very important we understand this flow. So developer basically writes code and then test on laptop, perhaps test code on laptop. Okay. So if code is good, it will move code to repo. So this is push to repo. So basically we push this code to repo. So this is like GitHub code, something like that. Okay. When the code is in repo, so it's done is test the code on laptops, write the code, test on laptop. By the way, this could be a DevOps guy also testing a Terraform code on something. So when you test your code on your laptop, your code is good, you push it to a repo. At that point, you want to test code in development environment, dev environment. Okay, so they probably want to test code in dev environment. So when the code is in repo, code gets pushed down, which we have seen they're going to do it git clone into dev environment. If it's good, they will probably move then test code in pre-production environment, pre-prod. So all this is still test. Code fails, so success is successful, success. Then they move it to pre-prod, they move the code and test in pre-prod. If the code fails, it goes back to here. Let's make it that. Please bear in mind, let me just make this a little bit clearer. Okay. Achieve this. This is more difficult than I thought. Okay. Well, so fail. So let's say now the guy writes the code, it tests on a laptop, it's good, it pushes the code to repo, and then the code goes to a test code in dev environment. So this is going to be like in the cloud. So the cloud is here. Okay. Let's move this forward. Let's move this forward. Let's put a little cloud here. Let's just contract it. So cloud So the code move into GitHub, the cloud, and then it go to dev environment. And then basically they test the code in dev environment. If the code is successful, they move the code to pre-prod. And then you have people testing in pre-prod as well. If it's successful, they will move the code to production. This is where people now actually begins to use the code. So the code is moved to pro. And these are all machines and different environments. So success, the code moves to production. So this is how typically it works. It doesn't like set in stone, but this is the general flow of things. So if they write the code and the code is good, they move it to dev and they test. If they find a bug, they move it back to here. Okay. So the process of pushing the code from the cloud into dev environment and testing is what they call the automatic build and test. So anytime the developer commits his code into GitHub, pushes his code into GitHub or a repo, ideally what should happen is there should be automatic download of the code into a dev environment and automatic testing. And this is what they call the CI, the continuous integration. So if the test fails, the developer is informed automatically and then it will fix his code and then the flow goes again. So this CI might go on for a long time. Write code push, test, write code push until the developer gets his code sorted. So this is very, very useful if you have a process of automatic download of code into an environment testing because it speeds up code finding of bugs, catching of bugs, and the fixing of the bugs. Okay. So essentially the CI part, this is what it is. So write code, push to repo, automatic download, test, and then success, move to the next stage, fail, go back to developer and then developer write his code. This is good because if you don't have a way of automatically testing, they just basically move everything maybe to production, you'll be catching your bugs in production, and that would impact your stability of your environment, confidence of customers in your solution, and so on and so forth. And it will give you good rest of mind because you will find you catch bugs early using this approach. You get faster feedback because you can see what is going on quickly, and you have less painful release. Release is the point where you actually go to production. This is called release, where you actually go to production. You don't want to be finding fault in production. This is what they call the fail fast approach, where when you're going to fail, you fail quickly. You don't delay your failure. You fail here, you fail fast, fix your stuff. And that's what we call the shift left approach, whereby you find things on the left side, not on the right side. Because when you find anything on the right side, if you look at this as a flow, the earlier you find things on the left side, the better. If they never find it code here, this is the leftmost side of the flow. So if you find your code here, your bugs here, that is good. So that means they can quickly fix the bug here. If you find the bug here, that is good also. If you find the bug here, that is good. So you shift your finding left, or the fail fast method, whereby the approach is to detect bugs early and fix them. If you're delaying that, you are basically going to be finding fault in pre-production and production. That is not good. And that is the whole essence of continuous integration and continuous delivery. So the continuous integration here is the continual test and resolution. Continual test and then this is the CI. The CD here is the deployment. So when you move from dev and you're moving to pre-production and production, you are doing the CD part. And this is the CI part. CI, continuous integration. It is up the way up to here. From here up until here is the CI, and the CD part is this. Because here you are not really like doing auto testing anymore. You are just doing the delivery, the deployment. That's why they will call it continuous delivery or continuous deployment. And it's continuous because ideally it should be automated. If this pass and is good, it should automatically deploy. So continuous means it's ongoing, and ideally you don't want to reduce the manual intervention as much as possible. But remember, we are not doing anything in an automated fashion yet. Good. We are using Terraform to now lay out our infrastructure. Be it Terraform, our Terraform knowledge is still very, very limited, which we are going to build on. And the code execution is still 100% manual. So we will log onto machines and we'll basically execute whatever code that makes a Python, Java, or HTML works. So we would then now begin to move away from heavy manual touch to using automation. And that is where CI/CD comes. So the way the CD comes into play here, obviously CI/CD here, is you're going to have an agent here. So let's call it agent. So ideally what the agent does is the agent monitors your code. So it just monitors, it looks, it's keeping an eye on your code. So anytime you be a developer, maybe writing Java code, Python code, HTML code, or a DevOps person writing Terraform code, whatever, there's an agent that is checking your repo. Anytime it sees a push into the repo, it would fire an execution that would basically automatically target a machine and then have your code deploy into a machine and then automatically run a test. And that's what the agent would do. So literally what we would do manually, which will be, okay, after we download, push the code into a repo, instead of now going on the machine and running git clone and all the rest of it, the agent will automatically detect that. And the agent will automatically do what it needs to do, and it will feed us back. So we won't have to find machines again to manually run git clone, git this and that. That will be managed by an agent. And that agent is the CI/CD agent. And the agent can even go as far as these other ones as well. So if things pass, it can automatically move things all the way into test. Test is good. It can then deploy to pre-prod and production. So technically, in some situation, what you need to do, basically, or what you have to do in some situation, basically stops here. So you write your code, you push your code to repo, and that's the end. The other things, it will just be automatically managed. Obviously, there's a caveat to that. Some people don't like that. They don't want to release into production in an automated way. So they will probably just only allow automation up to this point. And the production and pre-production release, they might do that semi-manual or fully manual. It's just to put in guardrails, checks to ensure that they're not inadvertently breaking stuff on the system and putting production in danger. So they might say, okay, we were not going to do production release using automation. We will do it manual or semi-manual. But this agent can go as far as doing the dev work for you, doing the test for you, pre-production, and even doing production release. So it can automatically manage all that. And this is what they call the CI/CD tool. This is what I call agent. Here's the CI/CD tool that basically manages that for you. There are a lot of CI/CD tools out there. There's a plethora of them. And they're just way too many. So I'm just going to mention a few names. So the number one, they used to be the number one king back in the day, was a platform called Jenkins. It used to be like the dominator or the most common platform that serves as, if you like, that agent that helps you with CI/CD. It's very popular and we're going to exploit, but it's by no means the only one. So if you are on so beauty about Jenkins is platform agnostic. So you can use Jenkins to target your cloud and AWS environment, Azure environment, Google Cloud environment. Jenkins can plug into them, and that could serve as your agent. So you can target AWS cloud, Azure cloud, Google cloud, even on-premise system that are not cloud-based. You can target them. Also, each of the cloud vendors, each of them has their own sort of CI/CD tool as well. For example, there's Azure DevOps, which you can then use the pipeline in Azure. There is AWS pipeline. So they all do the same thing. So Jenkins, you have Azure DevOps pipeline. You have AWS Code Deploy, it's called Code Deploy. So you have one called Bamboo. You have the GitLab, you have GitHub Action. We're going to look at that as well. GitHub Action. So these all basically do the same thing, but it's just like they're managed on different platforms. So the way you write them, the way you write their code is a little bit different. These are all also code based. So the instruction you give to them to do your automation for you, the instruction is code. So you write a code that tells them to maybe find your repo and then push to into an environment and test. So you will explain that all that to them using code. The way you write their code would differ because they use the different domain specific language. So, but they will essentially do the same thing, and the structure is usually similar. So I think for us, it makes sense to explore Jenkins because we can't look at everything. So I would say whatever one you are comfortable with, for example, people that already have existing knowledge, you just use what you are comfortable with. I think for people that are on Azure, there's nothing stopping you from still keeping using Azure pipeline. In fact, you can move your repos from GitHub into Azure pipeline and just use that. We're going to look at GitHub Action because that is popular too. So I'm kind of going with the ones that are platform agnostic and popular. So Jenkins is very popular. GitHub Action is popular. The beauty about GitHub Action is that we don't have to do much to use GitHub because we're already in GitHub. So if we want to start adding code, we just basically go to Action and then write some code, and that the code basically begins to manage our deployment for us. So we're going to look at that. But because Jenkins is quite ubiquitous as well, it's kind of losing momentum, but it's still very popular. So we're going to look at that as well. So we're going to start with Jenkins as our CICD tool, and that's what we're going to look at today first and foremost. And we're going to begin to see how we begin to pivot from using a manual means of executing our instructions or our code on platform to using automation. In this case, Jenkins to start with, and at some point moving to GitHub Action. So where exactly is Jenkins? So Jenkins, as I mentioned to you, is open source automation server. It runs jobs and pipelines. It will basically maybe things like, in our case, finding a repo, pulling the code down into a machine and running some things. All the things we've been doing manually, we can do that with Jenkins. So let me give us an example. Okay, so I guess no, let's not do that. So let's start with, basically demystifying this Jenkins. So the first thing we probably need to do is let us look at Jenkins and see what it can do for us. Remember, all we're trying to do is move away from SSH into a machine, git clone this, git install that, blah, blah, blah. We want to move away from that and using Maven and all the rest, all those manual work, we want to give it to an agent to do for us so that that will be automatically managed, obviously leveraging the CICD tool. So when you hear the word CICD, just remember is how you automatically run your code. So you have a lot of tools out there, Jenkins, Azure DevOps, Azure Pipeline, AWS Code Deploy, Bamboo, GitLab, GitHub Action. It's a long list. Right. So let's look at what Jenkins. I'm going to start everything from scratch. And whatever I'm going to do now, you can do it on any platform because Jenkins itself doesn't exist anywhere. Unlike GitHub Action, which is already in Git, so you can go to Git and start writing your GitHub Action code. In fact, this is the one that is getting popularity now because it's always just good to go. And we're going to look at that at some point. But let's start with Jenkins. Jenkins is a bit different because I always call Jenkins Mr. Stupid. It's because it doesn't know anything. You have to explain everything to it. And it doesn't exist anywhere. You have to set it up. Unlike GitHub Action, that you don't need any setup per se, you can just begin to use it. Jenkins on its own doesn't exist anywhere. So you have to stand it up and then you configure it. What do I mean? So for Jenkins to work, you will need a machine. And you have to basically create that machine. EC2, for example. and then you will install Jenkins. Install Jenkins, and then you can begin to use Jenkins. And that then becomes this. That then begins to manage all this thing for you. Okay. So let's set up a machine, install Jenkins, and that can be our CICD tool that helps us with all this, tedious work. I hope this is making sense so far. So let's look at Jenkins installation. So we go back to EC2. Boom. So we're going to launch an instance. We're going to call it just Jenkins server, something like that. Again, this is infrastructure as a service. So it's just going to be a VM, and we're going to do all the tidying up ourselves. So we're gonna use AWS. We keep everything the same. T3 micro, blah blah blah. We'll do this masterclass. I'm not gonna change anything here just yet. I'm gonna come here because we're gonna need a special port for Jenkins, which is port 8080. We're gonna keep it nice and simple now. We'll launch, and then we'll wait. And then the first thing we do is we update the security group, allow port 8080, because that's where we're gonna connect to Jenkins. So we've not done any installations yet. So it's just spinning up the VM. Okay, so we go to security. We're gonna find the security group. And then we're gonna go to edit. We're gonna add a rule. We're gonna say custom TCP. We will say 8080. That's the port where Jenkins runs. And then we'll do 00 here. We'll say rule. Okay. And then we go back to instances. So this is our Jenkins server. We can connect to it now. And then we can begin to prepare our installation. Right, so we've got the machine good to go, ready to receive instruction. So Jenkins, let's go back to the diagram. Okay, so okay, we got 10 people. As the vote going, let me just have a quick look. 10th. Okay, it's looking like 10. Okay, 10. I think it's gonna be 10. Okay, cool. All right, cool. That's all right. Right. So for Jenkins to kind of work, for us to do the installation, remember we want to install Jenkins now. We need port 8080, runs on 8080, port 8080. And Jenkins needs Java. Those are the two things that we're gonna need. So it runs on port 8080 and needs Java. For you to install Jenkins, you have to enable port 8080 and you have to install Java. Okay, so we're gonna look at that. So we will go here and then we got the machine here. And then we install the corrector Java, blah, 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 which we've done before. So we say sudo lowercase, sudo yarn install, I can type, install Java 17, Amazon corrector, corretto. That's the one. That's the one we need. Suspect. Let's see. So this is the Java binary that we need for Jenkins to work. Because I'm using a very ideally Jenkins needs a big machine that has high CPU, space, memory, and whatnot. But actually, because for training purpose, I'm using a very small machine. This should be good for it. but we might have some challenges and we might have to do some cutting some corners. The reason being that we're using a small machine. But it's not a big deal, but we should expect that. So ideally, you need a bigger, stronger machine for your Jenkins. So I'm making it super easy. There's some things I'm not talking about here deliberately, but at some point we will come to that. But the Java installation is nice and simple. And then what you need to do is you need to essentially set up Jenkins repo. This is not Jenkins repo. This is just binary to install Jenkins. Let me share that here. Let's see. I'm going to put the command here. I'm going to talk about it. These are Linux things. So what we are doing here is we need to install Jenkins. But Jenkins, if I say install Jenkins now, it won't find Jenkins. I think I need to do that so you understand. This is all installation, a one-off thing that you would normally do. But let me explain it, because if I just sudo, for example, if I say sudo yum install Jenkins, just to install it, you won't find it. So Jenkins does not exist because everything that the system find install, they are the location where the binaries are, the system needs to know. So what he's saying is, I don't know where Jenkins is. I can't install it. I can't find it. So for you to find it, you need to basically download the Jenkins repo information. So what this is doing. This is saying, okay, I'm going to tell you where to find Jenkins repo. This is essentially what is happening here. Okay. And also there's a key that Jenkins needs that needs to be made available on the system. These are all installation stuff. So don't worry about this. You can just do all this. I'm going to share the command. I'm just kind of explaining it, but you don't really need it. For the system to know that the binary that you're downloading is from Jenkins, so it needs to kind of get some key information to check it so that you're not downloading dangerous fake file from a hacker. So this is where the system will do the key comparison. This is not important. So if you don't understand what I'm saying, don't worry about it. But this is what Jenkins is. So when you do now the install, because you basically specify the repo where you should look for the Jenkins binary, you would use that and else you'll find it. Then you will install. So this should pretty much set up the installation for us. And then if the installation is successful, we can begin to use Jenkins as a service. We can say sudo systemctl start Jenkins. Jenkins should start running. Okay, probably the first start might take a while. Yeah, and then we can do status Jenkins to see if it's running. Status. And then you can see it's running, it's all good, blah, blah, blah. 8080, blah, 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 blah. It's good. And the good old boys online now. So if we go here and just get the URL, the machine information, just go here, Jenkins server, copy this name, go here, and then we'll put port 8080. Should be able to get to Jenkins here. Yep, and that's the Jenkins. So it's running. But it's saying, okay, it's running for the first time. It wants to know that you're in charge of the system. You need to do some setup. And it's saying there's a file on the server. Go and find that file. It's just testing if you're actually the one in charge to set this up. If you don't have access to the machine, that's cool. You don't have access to the machine, you will not be able to find what is asking you. Saying, okay, we need to set Jenkins up, but I want to go on the machine and find what is in this file. So obviously you have to have access to the Linux machine where Jenkins is running to see the file. All you need to do here, just say sudo cat just to see the file. There's some key in that file that you need to supply. You can see there's a key there, and you copy that key carefully. Don't copy any other space because some people copy like this. They copy with extra space. Pardon me. Oh, people copy like, oh dear. Some people will copy like this, and they will copy like this, and they will copy extra space. Always be careful. When you copy, make sure you copy. Man, just making this mistake all the time. So, anyways, copy and make sure your copy stops there. Then still right click and copy, and then we'll bring that here. Sometimes just for good measure, what I do when I copy stuff, I want to see it. I just paste it there. I want to make sure it's correct. Yeah, just for good measure. Okay, I know this is correct because I looked at it. So I just go on. Not now. I'm going to save it. So now Jenkins is saying I'm good. I need some plugins. I'm suggesting you install some plugins, but if you know what you want to install, go and install it yourself. Gonna keep it nice and simple. I'm gonna go with Jenkins suggestions. So all it is doing here is all the plugins that you're gonna need, like for Git, for Terraform, and all the rest of it. It would try to install it for SSH, long list. It will install those those plugins for you. It's just to make our life easier. When we begin to use Jenkins. So we'll go back to our little diagram. So this setup is happening here. Potato is installed, is configured. Java is installed. Jenkins is installed. And now we are at the point where we will basically get Jenkins standing up. I call it Jenkins stupid because it cannot do anything on its own. So everything that you need Jenkins to do, you have to literally explicitly speak to tell Jenkins what you want to do. So all we're going to be doing within Jenkins is building jobs and building pipelines, which we're going to see now. Okay, right. Let's see where we are with the setup. The setup should be easy. Okay, now it's all done. It's asking for creating an account. I always go with admin, 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 admin. I do admin, admin. I just basically .com like that. Just save and continue. I don't save it. Not now. Never. Yeah. So now it's saying, yeah, this is how you're gonna connect to me, and I will save and finish, and then we are ready to rock and roll. So this is Jenkins. It's nice and easy. You've installed it. It's all good. So we are still at the stage. Okay, so it's all good here. Jenkins installed, and then you can begin to play with it. Also, you might notice, if you've done it on EC2 users, you will notice something here. So what Jenkins is saying is, I'm not happy. I can't run anything because you are giving me a very, very small system, and I cannot use that system. So the information also is here. Okay, let's not go here yet. Let's not go here. That'll complicate things. Let's keep it simple. So it's saying, I'm offline, I can't run anything. So basically the way Jenkins journal is, it has like an engine that basically, they call it agent, that basically execute all the tasks that you need to execute. The agent is not happy it's offline because of some reason. We can look at it. So it's saying I'm offline. So I basically click on that. So you might see the use minus 6. Currently it's saying that I need 1 gig of space, but I only have 440 gig meg of space in my temp directory. So it's saying I need more space to work. I need a bigger table because I'm going to be I'm going to be doing a lot of work. Or maybe I need a bigger kitchen. The kitchen you're giving me is too small because I'm going to be cooking a lot. They're giving me a small kitchen, I need a bigger one. So if you look at what he's saying /temp is too small. I need a 1 GB. I've got a for whatever 400 with some change megabyte, and I need 1 GB. So this is 1000 megabytes that you need. We only have about 450. What's it saying? So if you go here and we check what our disk. So what it's talking about here is not memory, it's not CPU, it's just disk, which is like your hard disk. Saying there, the disk I have to work with on in temp directory is too small. So the disk space is too small. We can look at that. So we can say the system should give us disk df for disk space and minus h human format. And let's see what the disk space looks like. So it's saying temp. You can see this is used. We've used 4 meg and we only have about 448. So this basically chimes with what the system is reporting. It's saying available is 448. But I need 1 gig. That's what Jenkins is saying it needs. You can see 447 with some change, 448. And but it makes 1 gig. So if it doesn't have that 1 gig, it won't work. So what we can do is we can override it and say, dude, forget about it and just work with what you need. So we can set the threshold to, instead of being 1 gig, we can just crack it lower. Just go to here and then we'll say, where is it? Let's go to, I think is configure, suspect, yes, configure. And then we're gonna say disk space and monitoring. So if you don't do that, it won't work. And the reason why we're having this problem is because we are using a small machine. So just remember that. So just a display monitoring threshold, we'll click on that. And then we go to free time threshold here. So I'm saying 1 gig. Just gonna change this to maybe 100 MB. It's 100 MB and then basically reducing it, save and apply. And then, so we've changed it and then we say bring the node back online. Load back online. So now it's changed. You might need to click that twice. Now we don't have that warning anymore. If you don't fix that, you would not be able to run anything. So you might have that problem just saying, in this situation, if you're using a huge machine, you probably won't come across that problem. But because we're using a small machine, because obviously this is all test purpose and learning purposes, you might run into that problem. In fact, you will run into that problem just because of the sheer size of this temp directory. Because by default, when you install a machine on using AWS EC2, your temp will be around 400 meg. And by default, Jenkins will have for 1 GB. So you might need to do that little exercise just to kind of get out of the way. So why obviously that is out of the way now, we can focus on the meat of the matter and begin to play with Jenkins. So now Jenkins is installed, we're good. We are definitely here now, we're off and running. So what we want to do with Jenkins is begin to look at how job creation looks like. A lot of things we're going to be doing now is just creating jobs and in form of pipeline and so on and so forth. So if you look at Jenkins, we can go and say we want to create a new item. So what you can create here, you can create a freestyle project, you can create pipelines, you can create multi-configuration projects, you can create folders, you can create multi-branch pipeline. It's a long list. The way to kind of start is you can begin with a very small hello world just to see what pipelines is and how it works. So we say, let's do the hello world. Hello world. And for hello world, we're going to choose freestyle. Okay. And then we're just going to create something like that and as our item. And then we're going to create as a freestyle project. And then we have it here. So this is all the things that we need to set up to kind of get moving for this hello world item or job. So here I'm going to skip all this for now. I'm just going to do something very, very simple and straightforward. All this will become familiar with at some point. But for now, it's just start nice and easy. So we're going to come here. We're going to come to build step. I'm going to say, okay, add a build step. And then we're going to say execute shell. So what I'm doing here is I want to write some Linux command that Jenkins will run on my behalf on this machine. Remember, Jenkins running on this machine. Okay. For example, let me show you something. So on this machine now, I could say something like, I could go to CD temp directory, which is where we were earlier. And I can basically create a file. I can say touch, create a file. I can say touch, Ahmed, Ahmed. Ah, touch Ahmed. Basically, I'm creating a file called Ahmed. If you look here, that's the file created. This is me doing things manually. I'm just doing that as an example. Yeah. I remove the file. So, for example, you might want to create a Jenkins job that basically creates a file. So let's say we want to create a file on a machine. And obviously, we don't want to be logging on that machine. We want to create it as a job. It might be a simple case of just saying touch. So touch, we're going to create a file in temp. So touch temp and touch hello. So that will create a file, and then we can say echo hello file created in /10. So this is all us announcing that the file has been created. So this is the command we want to run. We want to create a file and we want to see, say the file has been created. So what would happen is Jenkins would execute this command on our behalf on this machine. So if you look here now, ls temp, hello does not exist. Okay, so if you cd to temp, even to check ls minus ltr, there's no hello file there. But now we are creating a job that will create a file. Touch is to create a file, and then we'll announce that the file has been created. So this is all we're doing. We're not touching anything else. We just come here, build, execute, blah, 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 apply, save, as easy as that. And then we can begin to build. So you can say build now. If it's good, it would announce here. It's going to be a green. You can see that as a green tick means it was successful. Then you click on that green, and then you can look at the outputs. You can see what is done. This is all logs. And it's telling you what's done. Okay. And then obviously what is reporting is not as important as he actually done the work. So if you go here and then you check on the machine itself, you can see the yellow file and it's created by Jenkins. Can you see that? Okay. Of course, we can still go on the repo, on the job, and then we can basically go back to the job and then configure the job and then go back and then say touch remove RM and say hello file removed. Hello file removed from temp. Okay, apply, save. Of course, we have the file here currently now. Still there. So when we run this code, build, and then this shows. So it's done it. And then if you check that just to see if we could measure console output, can say that hello file has a success, right? If we go back here, you see the file is gone. So this is us using pipeline to do our work. Of course, remember, don't let's be a little bit imaginative now because what we're doing now is still very basic. Everything that is happening is happening. It's not even touching any machine. It's not talking to GitHub. It's just Jenkins playing with itself. So the Jenkins running on this machine, whatever it's doing is running on this machine as well. So it's not talking to any machine. It's not doing anything in GitHub. It's just a very humble beginning. Everything we are doing is just like, it's like you want to run, you're just stretching your legs and you're doing your sort of pre-race rituals. And that's what we're doing now. So, but the little beginning is very important because we're establishing a sort of the mindset we need to have to working with CICD too. I said to you, they're very stupid. So you have to tell them exactly what you want to do and they will do it for you. But they're not like your AI system that are very imaginative and stuff. But look at this now. Obviously, we are removing the file, we're echoing. If I run this again, I'm not going to change anything. You see, this job will fail now because the file it's looking for will not exist anymore. So the remove would fail. So what do I mean by that? So we need to see what things look like when a job fails. So the RM here would fail because there will be no file to remove. That's what I suspect. So let's run that and see what failure looks like. So build now. Okay, can see it's a red. And because obviously you couldn't find the file, can remove file, no such file directory. That is expected, of course. And so this is what failure looks like. So you can look at your pipeline and you begin to see history of what was done, for the success or a failure, and so forth. Okay, and that is just a little beginning. Now, if we kind of look at things a little bit further, so we go back here, and then we look at new item. So we begin with Freestyle project, and this is us basically writing some shell script command and then putting it as a build sort of shell command to execute, which is what we've looked at. The another a little bit advanced option we have is pipeline. So we're gonna say pipeline one, can call it that, pipeline one. And then we're gonna select pipeline as our option, and then we're gonna go. Okay, here, what we're gonna do is we do not have the shell options anymore. What we have is a beautiful pipeline option. Okay, and here we can begin to use Groovy script to do things a little bit more advanced.
Sorry,
Yep,
I'll be
Cynthia.
raising my hand. Before you move to the next one, I
Mhm.
have a question in the build.
Okay, all right.
So what you did was to configure things in the current machine that you have your Jenkins in.
Yes, yes.
My question is, can we do same in other machines, not the one? So
Uh,
right.
Absolutely.
Can you have a reference to something
Mhm.
else? Like
Absolutely, absolutely. And we're gonna do that. And just have to be a bit patient with me. Yeah, because obviously what's the point where you have your pipeline code, your Jenkins agent only doing things on his own and it can't reach out to other machines. Obviously, this diagram then becomes useless. Yes, ultimately we would be touching other machines and I'll be doing things remotely on those machines. I think maybe tomorrow or day or next week. Yep,
okay,
cool.
thank you.
You're welcome. Right. So we go back to the pipeline stuff. So we go here, we go configure, da, 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 da. So the pipeline is a little bit more advanced because you can begin to use what they call Groovy script to basically say the same thing. Okay. The way this works is that you basically write the code. Let's see. So say something like this, pipeline to start with. In pipeline, then you have to say you want to use an agent. You can say agent. You can say agent any. So we're not really specifying any agent. But what is important here is you have to define stages. See, we don't use any agents. We don't need this. So the next stage is you have to define your stages. So in the pipeline, so pipeline is like first step, what you want to do, second step, what you want to do. So you define stages. You can say stage, and then you can say something like say uh, say hello to Cynthia. That will be the first stage. And then in that stage, I don't like this. And in that stage, we can do echo. Hello, Cynthia from. Okay. So like that's the stage. So we are doing that. So that's in our stages. We can have another stage, maybe stage. And on the stage, and then it's gonna be Cynthia. Say hello to Ahmed. Hello, Ahmed. And then maybe say hello to me. And me, and you can see what's happening here. So we have stages. You can check. Okay, so you can see there's something is not happy with because I've missed like a closing call for this one. So this one starts here, finishes there, starts here, finishes there, starts there, finishes there. There should be one that ends for that one. So I will probably put that here and it should be happy now. Okay. Da, 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 da. Let's see. What's that was you not happy with? Expecting what? Oh, am I leaving anything? What am I missing? Okay, bear with me. Let me see.
The agent part, is that how to pass it?
Agent. Yeah, agent is fine. Agent is easy. So I think it might be this one. Okay, I'll tell you what. Let me just make it nice and simple like this for now. Sometimes it's just crazy. There might not be anything. In fact, there's nothing to be honest. Let's see. There's something we do with it. So apply, save. Okay, let's have a look.
There
So
is no step.
there's no step. Yes, I think you may be right there. So let's have a look. Edit. Yes, you're right. So I missed steps. So thank you very much. So in a stage, you have to have steps. So in a stage, you can just get this stage. What step do you want to take? Thank you, Dr. Good call. So let's take that out. That's the danger of running things in real time. So, so in stage, you can have different steps. So you can say maybe steps, and then you can specify the steps you want to take in a stage. So steps, yes, in Echo Jenkins, that I like to align my stuff a little bit just to make it good. One, two, to echo from right, right. So this is that, and that one, two, one, two, one, one. So one, two, one, two, three. Yep, that's it. So let's keep it as one and then we can add other stages. So stages, stage one. Let's apply that. Actually, I want it to be many, so we will see it in its glory. So one, two, one, two. Let's do that. Boom, boom. Okay, so to Ahmed, Ahmed, to
You have to use my name.
okay. See that. So we go in now. So that's all you can see essentially is stages, stage, and the steps you want to take, and so forth. So we apply, we save, and then we build. So we build now, and this is will be a little bit different. You can actually look at things in real time, so it's already done, but you can look at the console and then see what it's doing. But the beauty about pipeline is that you can have a pipeline overview, so you can see what it's doing. You can see, boom, boom, say hello to Cynthia, boom, say hello to Ahmed, say hello to Mumi. Then you can actually drill down and see what it's doing there. Drill down, see what it's doing there. Drill down to what it's doing there. That's what it's doing there. Okay. Of course, this can be a little bit more complex than that. So if you go here and then you go to config, instead of saying hello, hello, this could have been maybe checkout from repo. So you can say maybe checkout. Obviously, the name here doesn't do anything. It's just a label. Checkout code, repo. What we are doing here, we are not actually doing anything. We can just say echo this downloads code. And this stage probably would have been maybe build. You can say, you can call this building the application, something like that. Building, B-U-I-L, building the application. Application. Okay, and then maybe this would have been another, maybe testing the application. Test. And this would have been running test. Let's just go like it's doing something. Of course, we're not doing anything. Okay. And then maybe deploy to next environment, deploy, and then deploy to new ENV and so forth, right? And then obviously those are our steps, now stages. And then sometime when you finish your stages, you might need to do maybe post operations. Maybe you want to do some cleanup, you want to do some things. It allows you to do post, which are like post operations that you want to do. And in there, you can, when things succeed, you can define what you want to do when you have success and when you have failure. So for example, when everything is successful, you want to do some things. When things are not successful, you might want to do something else. So I can say pipeline succeeded. Succeeded. I hope I'm right with the spelling. You know, let's do that just to make sure. And then we can also have like fail, which is like failure. And then we can say something like echo pipeline failed. Honestly, it's as simple as that. So 1, 2, 1, 2, 1, 2. And then it should be good. Apply. Let's try it again. And then let's build now. And then it's good. Now we can go have a look. And you go to pipeline overview. And then we'll see here now. Check out jet code from Reaper, build, test, deploy, post action. Right? And it's all kind of looking good for us. And now all this is just pretend work, right? Okay. So what we could do next is we can actually check out the code. For example, I have a repo here, right? So I have a repo here. This is my repo. So for example, I want to bring this repo onto the machine and maybe play with it. I'm not going to do too much stuff. I want to be able to see this repo and list it. For example, I could do like git clone and then list what's in the repo. I can do like git clone this and then go into it. If this is a fruit market stuff, and then we'll list what is in there. So ls minus ltrs, maybe git clone that. Now remember, so we do something like this. Git clone that. Let me do that on my local machine, what I want to achieve. So copy this. I'm not going to do it on the Jenkins pipeline. But just imagine this is my machine. Yeah, this is my local machine. I could do something like git clone that repo that clones it, and then I can seed it to the clone, and I can list what is in there. Yeah. So you might want to automate this just these small steps using your pipeline because this is taking things to the next level now. So the next level is basically talking to a pipeline and doing the clones. For example, where we have here, okay, go back to pipeline, configure, where we have the check out of code from repo here. This could now be serious stuff. So we can then say step, and can we say instead of saying echo, instead actually saying it, we can actually do it. We can say something like we're gonna use git, and we're gonna use git what we call the git plugin, which is in Jenkins. We use git plugin and we're gonna target the branch. Let's look at the branch. We're gonna target the main branch. You can just say git and then the branch is main. Okay, and then we can specify the URL we want. Let's say URL. URL is okay, and then we'll copy that URL. So this is what we want to target. And then we'll come here, and then we'll put the URL here. I can then say, get URL, I can say, if you succeeded, we say code downloaded. This is gonna fail. I want us to kind of walk it one step at a step by step so that we'll see why it failed and we'll fix it. Code downloaded. This is not gonna work, but I want us to see it first before we fix it. Okay. So git branch. What we're saying, we want to use git plugin to target this branch, to get this repo, and we interested in main branch because obviously your code can have different branches. This only have main branch here, but you can have more than one branch. So, and then we'll go again. This will fail. So, but let's see in action first. Say save, and then we would go and build now. And it should just crash. Yeah, it fails. So it's failed because it doesn't know how to use Git. So listen parameters, expert URL. Okay, this is even different now. So it's talking about a syntax problem. So okay, I have a syntax problem. This is not a failure because something is missing syntax problem. So let's check it here. I'm gonna show us later how to actually do this in an advanced way. So for now, it's just early days. I think I'm missing a comma. Yeah, I think. But we're gonna see how to do this in a more efficient way. But let's just start nice and easy for now. Let me run this. I'll still expect it to fail, not for syntax reasons, but let's run it. Okay, now it's doing the work. You can try to console, and you can see that it failed because it cannot run git command. Okay, it cannot run git command because it can't find git on the system. So let's go back again and have a look. So these are pipeline and stage 4 has failed. And you can have a look in the console. You have to get used to people. There are a lot of DevOps guys there out there who are like fake DevOps guys. They don't read, they don't like to read logs. Just let them know they won't last. So you have to get used to like liking logs and making sense of logs. So the log is your friend. It tells you everything that's going on in the system. So I look at this log now. The initial one, you can see the initial one we had. I had to check the log and I knew it was a syntax problem. So I wasn't putting in something that I didn't like it. Using required parameters, URL, I just figured out, okay, this is combat. So this error is different to the one we have in stage 4. Can go back and forth. I can just cheat and just put 4 there. Right, so stage 4. Can see it's saying that I'm trying to run this gate, blah blah blah, to initialize and do what I have to do, but I can't find gate, cannot run program gate. So what happened here is it's got the gate plugin, and this is one thing that people need to really understand about Jenkins. You need plugin to make your life easier. For example, whatever thing you need to run, like important binaries, for example, um things like Terraform, things like Packer that we're going to need later on. We would need there will be plugins for them that just make them easier to use within the pipeline system. But ultimately, the binary has to exist on the system. That means you have to install those binaries on the system, because the plugin is just like a cake, like icing on the cake. So you need the plugin, which is here now, but it's the icing on the cake. The real stuff, which is Git, has to be on the system installed. So plugin is not what's it called? It is not a substitute to the actual binary. For example, we have Git plugin, fine, but we don't have Git on the system. You go on the machine, for example, now, and then this is the Jenkins machine, obviously, because it's gone dormant. So let's go back here and just connect again, and then connect. And then we do, for example, if the test is on the server, the Jenkins server test gate, it doesn't exist. Okay, so we need to install Git. You can say sudo yum install Git. Yes. And this should clear the way for us. Now Git is installed. If it tests like the Git version, we're good. Okay, with Git installed now, the plugins would just automatically use that Git. So without changing anything, we should be able to kind of get this working again. So we can just basically replay, just rerun it, just run. So we can actually have a look in real time, console output. You can see now it looks good. It's no problems. It's downloaded it and it's done. So if you go and the platform overview, you can see checkout code and then Git, and then you see all the good stuff that is done there, code downloaded, blah, blah, blah. You can see it's downloaded code. Okay. So, and the build, obviously this is all message. So we can go back and then say configure, right? So Git code downloaded. We could go to the next step. For example, even in this step, we can do something like this. Shell command. And then here we can do something like can say ls minus ltr to see what is done. Okay, so list what is done. Let's check that out. Apply, save, and then we should see that directory basically being visible in the repo. So should be going now. Is it running? Is it not? Okay, so I've done real quick. So console output, you can see ls minus ltr. See that? You can see that it's downloaded it and it's showing us that the files are there. And So that's the content of the file. Okay. So obviously this is just training on the machine now. So what could have happened is, right. So we have a Jenkins server that is downloading code and stuff now. So what could have happened with the diagram is with this Jenkins. Okay. All right. Question. Go for it. I have to. Yep.
Just a quick one.
Okay.
The when you did git branch, then you kind of clone that particular repo. You did not cd into the folder where the content are actually saved, because when you clone a repo, it cloned a folder, and inside that folder that you've cloned, all the binaries are in there, the files, everything is in there, but you did not cd into the file.
Correct.
Automatically, the ls is listing everything inside that folder,
Correct.
but you're just going into it.
Yeah,
A
because
bit
that's fine.
okay.
Yeah, I mean, I get what you're saying. So the reason for that is because everything is happening within this step, and we are using what's it called? So when you use the Git branch, what's it called, plugin, what it does for you is it doesn't just download the code. It doesn't just download the repo. It will go inside the repo by itself. So for example, I could have decided not to use what's it called? I could have decided not to use the plugin. I could have literally done something like this, which is use a shell way of doing it. I could have done, instead of pipeline, I could say something like this, just git clone normally. So this is
Yeah, that's what I'm used
and if
to.
you
Okay.
do this, then you don't have that advantage of the plugin doing all those heavy lifting for. Does that answer your question?
Yes, thank you. Thank
Oh,
you.
all right. Cynthia, go for it.
Okay, I've been raising my hand. Okay, so my question is on the agent. So I just want to understand the concept because this is my first time.
That's a great question.
Um,
That is a
I want
great question.
I want to understand the agent because remember Jenkins is inside the machine, right? And the agent, how does it work? Because I can see you write agent any. So
Mhm.
does it have its own agents that can run our jobs, and can we use our self-hosted agents, and how is it configured? Like, I just want to understand the agent concept.
Okay. All right. The agent concept, I'm going to just touch it now, but we're going to do justice to it later. So
Thank you.
Jenkins it has a concept of server and agent, which is like slave. So the server is like the father that is like the orchestrator. But the agents are systems that actually do the actual heavy lifting. For example, so this is a Jenkins server. In an ideal world, you will have like two CVV. So this is a server. You can have maybe get something like maybe AWS agent. You can have Azure agent. So essentially, when you have a server set up, because obviously we are kind of doing like, simple operations, etc. But if you're looking like a company like, for example, Shell Petroleum, or maybe companies like, the UK government and all those big, big organizations, a single Jenkins server will not do because everybody will be running different jobs. So what they will have is multiple agents, a lot. For example, even the AWS agent, they might have tens of them. Azure agent, tens of. So these agents are basically machines that basically been they specialized to run different kind of code or sorry, to target different kind of platform. For example, if you recall earlier in here, we couldn't get Jenkins, we couldn't get Git running. I had to install Git on this machine. Uh, in an ideal world, you would have maybe if you have like you can have, for example, you can have like a CICD agent, for example, or maybe Git agent, something like that. And it is on that agent that anything Git related would work. So it is that agent that probably needs to run Git. The server doesn't run anything. You just basically your code, you will say, okay, I want to use agent gate, something like that. But you would have defined that agent. We will look at that at much point later. But agents are just specialized slaves
Okay.
that the server would defer tasks to execute.
Okay. So,
Mhm.
sorry.
Yeah, go
My
on. Don't stop saying
understanding,
sorry.
so from my understanding now is,
Mhm.
so the way Jenkins works is that it has its agent. So you can actually configure the agent, but based on the platform is running, not necessarily the hosting agent. So I think there are two ways to use, because that's why I was asking, like, what's the
Mhm.
concept of the agent?
Mhm.
Because
Mhm.
the one I
Because
understand is that
yeah.
you can have agents,
Mhm.
you can configure agents, you can
Mhm.
put whatever you want, you can have your self-hosted agent. Then it can actually have its own agent. You just make reference to. You don't need to configure or
Mhm.
write anything, because when you
Mhm.
said any, that
Mhm.
was what got me, because
Okay.
yeah. So
All
that's
right. So just to top up, the understanding you have is correct. The only thing is that's a bit different with Jenkins is everything is configured. So you have to, because obviously setting up the machine is something that you have to do manually yourself. The setting up of the agent will be another machine. They will not be this Jenkins machine. They will be
mm,
separate machines, okay? And
uh-huh.
then you will connect those machines. So it's those machines that needs to run whatever they need to run. Maybe on those machines you have Azure CLI to do all
Yes.
the Azure stuff. And
Yeah.
then you will, because the server will not run anything. But
Okay.
on here, you would then say, okay, I want to configure an agent. And
Okay.
then you would have set up the agent, and then you can go find the agent and just link it to the server. And then you give the agent a name. And then when you are writing your code, you can
You
specify
reference.
the agent you want to use. Does that
Okay,
make
but
sense?
the any you use now, does it mean that it's
Any means
the one we
is
spinned up now that you're using this?
exactly because
Okay,
everything
thank
is
you.
all in one now.
Okay,
Yes.
thank you.
Correct. Correct. Great question, by the way. So yeah, so in an ideal world, you would not be gonna, you're gonna specify agent, maybe Java, maybe this and that, and so forth. So this is where we are now. And then we've been able to obviously download code and use ls-ltr. So the natural step will be okay. So if we can go, if we're going by what we have done, of course, also, by the way, so we're just looking at the app side of things. We could also look at the Terraform side of things. This is the one we built the other time, I suspect. Blah, blah, blah. No, let me check. Uh, uh, So again, Jenkins will run anything for you. So let me see this one. 1, 2 on TechBit. So for example, just to build on what Cynthia just mentioned, so you could have like a Terraform agent that has Terraform and all the rest installed. And then let's say you want to build Terraform and you could just specify Terraform as an agent. Let me see if time will allow us to play with this. Let's see. So in here we have Terraform. Let's do one for Terraform real quick. I'm not sure the time will permit, but let's just see. So we got the Terraform code here. So what we can do is we can just want to make sure that time will be enough for us. Okay, let's have a go. We might not finish. Just okay. This is the Terraform code. I think a few things may have changed. The EMI, I think I may have deleted this and so forth, but it doesn't matter. Let's just have a crack. We might not finish. So we have the Terraform code here. So we can change this one. And then we're gonna see again how you're gonna need Terraform to do the work. So let's change the repo here. So what I'm doing here, for good measure, is we are looking at the infra side of things. We want to use Jenkins to set up our infra, so the VMs and so forth. So we're going to target that Terraform repo, which is this one, which we have played with in the past. We're going to run into some problems, but we're going to deal with them. And we'll probably continue from here tomorrow because I don't think we're going to finish. I think I like, sometimes just do things on the spot, at the spot, in the spur of the moment, just as the saying goes. Okay. If it's too complicated, don't worry. I will repeat this tomorrow. So if you don't fully understand it, by all means, we will repeat this tomorrow. So the repo here is this. So we will basically get this. I want us to do this on the fly so you kind of see how I'm building it because nobody, there's nobody that 100% understand it. You have to just build, and make it work. So now this is the repo. So what we're gonna do, because we're gonna do it for pipeline for Jenkins, so we can say check out code from repo. Obviously, we change this to that one now. Okay, we do ls minus lt here. What we can also do here is Terraform formats. Let's say Terraform. I'm not gonna do any. I'm not gonna do anything yet. But what I want to do here, I just want to see what the layout looks like. I'm gonna get all this out just to so that we can focus and do this thing well. Okay, stages need to close. Okay, so what I want to do here, I'm just gonna look at what I see. I'm gonna do sh ls minus lt. Okay, and take this out. Don't need that here. So all I'm doing here is I want to check out the Terraform code, and the next thing I want to see what the directory structure looks like. So I will know what to do and where to apply what I need to apply. This is going to be crude. Obviously, we can make this better, but this is another spot of the moment. Let's have a look together.
You need to CD now.
Don't worry, okay. I'm going. All right, so we apply, we save, and then we build. Okay, so it's all good. And then we look at the console, we're going to learn some things. So we can see that the code is downloaded. And when we check, we see Terraform and Packer, right? So I want us to kind of go along this journey so everybody understands it. So we've downloaded the code. And when we look at what we've downloaded, we see Terraform and Packer inside, right? And if we go here, we go to pipeline and we go to configure. We can see what we're doing, download the code and list what is inside. When we list, what do we see? We see Terraform and Packer. Of course, to use Terraform, we're going to have to go inside Terraform. Okay. And then we can do Terraform format and all the rest of it. Of course, if we're going to use Terraform, we will have to have Terraform installed on the machine. Otherwise, it would fail. We're going to have it go anyway. And then we will then try to trigger it. So what we're going to do, if you look at what we've got here, we got Terraform and Packer directories, okay? So what we probably should do is our work, we have to target Terraform infra, Terraform directory, and that's what we're going to target. So we're going to go inside the directory and do listing. So if I go here, please bear with me, I need you to understand this. So what I'm going to do for the second stage, I'm not going to list yet. I'm going to do step and I'm going to add something else. I'm going to say directory. I'm going to specify the directory where I want to do my listing, dir. And I'm going to say I want to use this directory, which is Terraform. Okay. I'm just kind of doing things on the fly. Please bear with me. If it doesn't work, I will figure it out. Terraform is the directory I'm targeting. So I will say dir is Terraform. That's a directory. I need to get a pick, look into that directory, and then do a listing. So if I do ls now, I should just see main.tf and not anything else. So that directory is Terraform, and in that is where I want to run this, if that makes sense. So the steps, and that step, I'm doing things within Terraform directory, and I want to list what is in Terraform directory. So let's apply this. It's about to go. Let's run it. Okay, this looks good. And this should look a little bit different. So console output. And you can see that what we see is the main, which is expected. You see now it's going to that Terraform directory and it's showing us that main file. Beautiful. Of course, the next step will now be to do maybe Terraform format check. So I want to use something like Terraform FMT check, just to kind of check that the code is good. Okay, so if we go back, you can see I'm kind of building this layer by layer. Okay, right. So I'm gonna list and then I'm gonna do something like SH. The listing is just for me to see what is there. I can remove the listing now. I'm gonna do Terraform FMT. I'm gonna say check. This is not gonna work because we don't have Terraform on the machine. And this is where the concept of agent comes in. So let's say we have an agent that runs Terraform, we would have specified agent Terraform, and that agent would have add Terraform installed on it, etc. But we're using like the server as the agent, as everything now. That's why we say agent Henny. This would fail because we don't have Terraform on the node itself. So if we go here, if it's frozen, it's frozen again. We'll go here and then we'll connect and then we'll do that. We don't have Terraform. Terraform. Version. Not there. So we expect this to fail. So if we run, it's gonna break here at this point because it can't run Terraform. Apply, save. There's now. We expect a rate there. So yeah, see that. And there's a failure, blah blah blah. Terraform command not found. Okay. And then we go to like pipeline overview. Let's see where the failure is. It just basically stops there. It couldn't go any further. If you contrast that to stage 8, that probably completed successfully. This Terraform and then stage 19 connect successfully. So, right. So stage 9 is fine. The only reason is because we don't have Terraform installed. So what we can do, just looking at the time, is we can basically install Terraform. All right, let's see. Let me get the config manager shikup repo. Let's do that real quick. And then we will stop there. Found it. It's that. Okay, and then we will then install sudo yum install. I always try to make people see the reason why we're doing stuff because we could have just done it and everything would just work. We'll see where it fails and then we all learn together. It's easier that way. And people are asking reasonable questions, which means we are all tracking it. Fantastic. This is good now. Without changing anything in the code, this should just work now. So I'm going to replay the code and then run again. And I'll expect this to work. Now it's green. I can say console output. I can say Terraform check. Check is fine. And this is where we're going to rest it. So tomorrow we will see how we build out our infrastructure. And then we're going to see the little configurations we need to make for our machines. So essentially tomorrow, what we do is we're going to use Jenkins to build this infrastructure out using Terraform. And then we're going to see how we configure Jenkins to be able to talk to this machine and connect to them and do things on them if time permits. So we will see how Jenkins can then begin to do wonders on each of these systems, basically connecting to it. It's simpler than you think. So I know you're still kind of thinking, how would you run this on there? How would you run this on there? You will see it's very simple. There's a bit of Linux thing to learn, but it's all good stuff. You're in good hands. So rest assured you learn it, you know it. Thank you, everyone. Any questions or comments before we wrap up for the day? All right. No news is good news. Thank you, everyone. Okay. Speak again
Thank you.
tomorrow. All right. Have a good one. Cheers. Bye-bye.